Hello, I hope you're doing well. In this video, we're going to solve a non-serial dynamic programming problem together. But before we dive into the problem, we need to briefly review the basic definitions of serial dynamic programming. One of the dynamic programming problems is the investment problem. For simplicity, we've drawn a schematic diagram of it. Following the standard approach for solving dynamic programming problems, the actions and solution steps are outlined in the table. We will explain the investment problem in more detail in the following slides. Now, the main objective of this problem is to invest over these 3 years in such a way that we maximize the profit, the objective function. In the next slides, we'll explain both the backward and forward methods. The necessary explanations are already provided in the text, so no further clarification is needed. The only point I want to highlight is the symbol V, which represents the return or profit obtained from investment at each stage. Just remember that in this method, the direction of movement in solving the problem is opposite to the direction shown in the diagram. Now, let's look at the details of this method in the next slide. In this problem, our initial capital, or initial value, is equal to 20. Now, the question is, how should we invest these 20 monetary units over 3 years to achieve a good profit? The solution using the backward method works like this. You imagine you are at the end of the 3rd year, and you've invested all your money, meaning your current balance is 0. You start from the last year and move backward to the present. Now, a quick note. Don't let the numbering of the diagram confuse you. Diagram 3 represents the present time, and Diagram 1 represents 3 years in the future. Another point, in these problems, V0 is equal to 0, meaning we have no capital in the 3rd year to invest, so we earn no profit. The only point I want to mention here is the symbol W, which represents the return at each stage. Just remember that in this method, the direction of movement in solving the problem is in the same direction as the diagram. Now, in this section, our final capital is equal to 20 monetary units. The question asks us to invest over 3 years such that 20 monetary units remain for you at the end, that is, in the 3rd year. In this method, the value of W sub 0 will also be 0. Therefore, according to the established equation, W sub 1 will also be 0, meaning our profit in the 1st year is 0. In fact, whether using the forward or backward method, we are looking to calculate variables like the capital available each year and the amount invested in each year. Everything we've discussed so far provides enough preparation to solve non-serial problems. The general information is in the text, but for more details, it's better to work through an example. First, a note. The problem doesn't specify the exact topic, so we can assume anything, but we'll stick with the investment problem. Let's see what information the example provides. 1. The example spans 6 years. 2. We have initial capital beta, 4, and beta 6, 3. The objective function is to maximize the total return over the 6 years. Now, we need to split the diagram into several branches and solve each branch using both the backward and forward methods based on the initial or final value. Finally, we'll calculate the optimal values of the variables and the final value of the objective function. A question. In the first branch, we don't have any information like initial or final value. So, how do we know whether to use the backward or forward method? Yes, you're right, but there's a point. Branch 1 is ultimately the final branch of the diagram, and we assume the remaining capital at the end of the branch is 0. Therefore, we use the backward method overall. Next, we'll calculate the optimal investment amount and the return for each year. A question? In branch 2, even though we have initial capital, why do we use the forward method? See, the final or initial value isn't always our criterion. We are actually trying to reach the gamma stage through branch 1 and branch 2. That's why we used the forward method. Before we move to branch 3, I need to mention one thing. We reached the gamma stage through branch 1 and branch 2. This means the return in the gamma year is equal to the sum of the returns from branch 1 and branch 2. Now that we have the return for the gamma year, we move backward. Finally, the return of the last node, v4, is equal to our objective function. which is the total return from investment over 6 years equal to 27,560. The investment amount for each year is also specified. In short, if you invest these amounts over these 6 years, your maximum profit will be 27,560 monetary units. Thank you for your time.